Download this code from codegive.com, link in the description below. OK, let's dive into the world of type length value, TLV, encoding. This is a widely used technique for serializing data in a flexible and extensible manner. We'll cover the concepts, advantages, disadvantages, common applications, different variations, and plenty of code examples in Python. What is TLV, type length value, encoding? TLV encoding is a data serialization method where each data element is encoded as a triple asterisk type, T, a field that indicates the type of the data being represented. This is typically a numeric value or an identifier. The type field tells the decoder how to interpret the data in the value field. Think of it as a label or descriptor for the data. Asterisk length, L, a field that specifies the length, in bytes or other units, of the value field immediately following. The length field allows the decoder to know precisely how many bytes to read for the data. This is crucial for handling variable length data and ensures correct parsing. Asterisk value, V, the actual data itself. This is the payload or content that the TLV structure represents. The format and interpretation of this field depend entirely on the type field. Conceptual example. Imagine you want to encode a person's name and age using TLV. You might define asterisk type equals 1, represents a string, example name. Asterisk type equals 2, represents an integer, example age. Then, the TLV encoding could look like this, in a simplified representation. Type equals 1, length equals 5, value equals Alice. Type equals 2, length equals 4, value equals 30. Here, Alice is a string of length 5, and 30 is an integer, which might take up 4 bytes, depending on the integer representation. Why use TLV? Advantages. 1. Extensibility. TLV is highly extensible. You can add new data types or fields without breaking existing decoders. Old decoders will simply ignore unknown types. This makes it ideal for protocols that need to evolve over time. 2. Flexibility. TLV can handle a wide variety of data types, including strings, integers, floating point numbers, arrays, and even other TLV structures, nested TLV. 3. Self-describing data. The type and length fields provide enough information for a decoder to interpret the data without needing prior knowledge of the data structure. 4. Forward compatibility. As mentioned, new TLV elements can be added without requiring existing applications to be updated. 5. Variable length data. TLV gracefully handles variable length data, such as strings or arrays, by explicitly specifying the length. Disadvantages. 1. Overhead. The type and length fields add overhead to the encoded data, increasing the overall size compared to some other serialization formats. 2. Complexity. Implementing TLV encoding and decoding can be slightly more complex than some simpler formats, especially when dealing with nested structures. 3. Potential for errors. Incorrect length calculations or inconsistent type handling can lead to parsing errors. Common applications. TLV encoding is used in a wide range of applications, including networking protocols. Many networking protocols use TLV to represent data packets, such as radius, remote authentication dial-in user service. LDP, label distribution protocol. MPLS, multi-protocol label switching. Diameter. Smart cards. Used for encoding data on smart cards, such as EMV, Europay, MasterCard, and Visa cards. Data storage. Can be used for storing data in a flexible and extensible manner. Asterisk configuration files. Asterisk sometimes used for configuration files where new options need to be added without breaking existing parsers. Asterisk telecommunications. Asterisk in various telecom protocols for signaling and data transmission. Asterisk file formats. Asterisk certain specialized file formats might employ TLV encoding for specific data segments. Variations and considerations. One-type encoding. Asterisk numeric. Asterisk the type field is often an integer. The range of the integer determines how many different types you can represent. For example, a 1-byte type field can represent 256 different types. Asterisk string / identifier. Asterisk the type field can also be a string or other identifier, but this usually requires a predefined mapping between the string and the actual data type. 2-length encoding. Asterisk fixed length. Asterisk the length field always occupies a fixed number of bytes, example 1 byte, 2 bytes, 4 bytes. Asterisk variable length. Asterisk the length field can itself be encoded using TLV or another variable length encoding scheme. This is useful when the length of the value field can be very large. Sometimes a special marker is used to indicate that the length is encoded in a different way, example the first byte of the length field has the most significant bit set to 1 to indicate that the length is encoded in the subsequent bytes. Asterisk implied length. Asterisk in some cases, the length may be implicitly known based on the type field. For example, if type equals 3 always represents a 4-byte integer, the length field might be omitted altogether. 3-value encoding. Asterisk the encoding of the value field depends entirely on the type. It could be a raw byte string, an integer in big-endian or little-endian format, a floating point number, a UTF-8 string, another TLV structure, etc. 4-endianness. Asterisk when encoding integers or floating point numbers in the length or value fields, be mindful of the endianness, byte order. Big-endian, most significant byte first, is often used in network protocols. Little-endian, least significant byte first, is common on x86 processors. You need to be consistent with the endianness used for encoding and decoding. 5 padding. Asterisk sometimes padding is added to the value field to align data on specific byte boundaries, example 4-byte alignment. This can improve performance on some systems. 6 nesting. Asterisk TLV structures can be nested. The value field of one TLV element can contain another complete TLV structure. This allows for complex and hierarchical data representations. Python code examples. Let's create some Python functions to encode and decode TLV data. We'll start with a simple example and then add more features. Explanation. Asterisk encode _TLV, type _val, value. Asterisk takes the type, integer, and value, byte string, as input. Asterisk packs the type into a 1-byte big-endian unsigned integer using struct.pack, b, type _val. Asterisk calculates the length of the value. Asterisk packs the length into a 2-byte big-endian unsigned integer. We use struct.pack, h, length, here. If you need larger lengths, you might use struct.pack, I, length, 4 bytes, or a variable length encoding for the length. Asterisk concatenates the type, length, and value bytes. Asterisk decode _TLV, data. Asterisk takes a byte string containing the TLV data as input. Asterisk unpacks the type from the first byte using struct.unpack, b, data 1, 0. Asterisk unpacks the length from the next 2 bytes using struct.unpack, h, data 1:3, 0. Asterisk extracts the value from the byte string based on the length. Asterisk returns a tuple containing the type, length, and value, and remaining bytes. Handling multiple TLV elements, decoding loop. Often, you'll have a stream of TLV elements. Here's how to decode them. Adding type-specific decoding. To make the decoding more user-friendly, let's add a function that handles different data types based on the type field. Variable length encoding. For very large value fields, a fixed length field might not be sufficient. Let's implement a variable length encoding where the first byte indicates how many subsequent bytes are used to represent the length. Explanation of variable length encoding asterisk. Asterisk encode underscore length. Asterisk if the length is less than 128, 0x80, it's encoded directly in a single byte. Asterisk otherwise, the most significant bit, MSB, of the first byte is set to 1, and the remaining 7 bits indicate the number of subsequent bytes used to encode the length. Asterisk for example. Asterisk 0x81 means the length is encoded in the next 1 byte. Asterisk 0x82 means the length is encoded in the next 2 bytes. Asterisk decode underscore length, data. Asterisk reads the first byte. Asterisk if the MSB is 0, the length is simply the value of that byte. Asterisk if the MSB is 1, the remaining 7 bits indicate how many bytes follow to represent the length. The appropriate number of bytes are read and unpacked to get the length. Important considerations asterisk. Asterisk error handling asterisk in real-world applications, you need to add robust error handling to catch invalid data, incorrect lengths, and unexpected types. Raise exceptions when errors are detected. Asterisk security asterisk if you're handling data from untrusted sources, be careful about interpreting the length field. A malicious actor could craft a TLV element with a very large length, leading to a denial of service attack by causing the decoder to allocate excessive memory. Consider setting maximum length limits. Asterisk customization asterisk the specific details of TLV encoding can be customized for different applications. Choose the type and length encoding schemes that best meet your needs. Summary asterisk. TLV encoding provides a flexible and extensible way to serialize data. By understanding the concepts of type, length, and value, you can effectively encode and decode data for a variety of applications. Remember to consider the trade-offs between overhead and flexibility, and always implement robust error handling and security measures. The code examples above provide a solid foundation for building your own TLV encoders and decoders in Python. Remember to adapt and extend them to match the specific requirements of your project.